So, for the next presentation, I actually have a full lot of 4 speakers for you. I am not going to introduce them all individually, so I highly encourage you to talk to them after the sessions. We have a broad spectrum of expertise from industry to research, presenting a joint research project. We have 2 speakers from Wastestream, John Sandell and Christian Buck. Then we have Burnham Shariati from Fraunhofer Heinrich Hertz Institute, as well as David Hock from InfoSim. They will present the current state of the research project Palantir, a research project for the collection and analysis of telemetry data from fiber access networks. The presentation will be twofold. They will present their data acquisition experiences in the Swedish municipality network, plus a project developed at Fraunhofer Heinrich Hertz, where they developed a field trial demonstrator for end-to-end simulation. And we will have a Q&A afterwards. And to spark you with a little bit of inspiration, they are actually actively looking for failure scenarios in fiber access networks to train their models. So if you have any, please approach them in the Q&A and we can have a good discussion.
So. Oh, sorry.
Könnt ihr noch mal kurz einen Augenblick warten? Ging ein bisschen gerade zu spät.
Good.
We should.
Okay, so we should wait. Yeah. No, sorry. No pressing. Yeah.
They need a few more seconds on.
Yeah. So we'll wait. No problem.
So let's wait.
Yeah.
Okay, because I was not deliberate in my timing and our process, I'm actually going to introduce it again for the stream. I am very sorry, but then you have it correctly in the recording. So we have 4 speakers here, 2 speakers from Wastestream, John Sandell and Christian Buck. And we have Burnham Shariati from Fraunhofer Heinrich Hertz Institute and David Hock from InfoSim. They will present a joint research project called Palantir for the collection of analysis of telemetry data of fiber access networks. The presentation covers their data collection strategy from 1,000 access switches, as well as the end-to-end field trial demonstrator developed at Fraunhofer Heinrich Hertz. And to get you, also the stream audience now sparked up for the Q&A, they're actively looking for failure scenarios which cause the majority of failures in fiber access networks. And now here we go.
Okay, thank you. So welcome to this session on the topic of anomaly detection in fiber access networks. I think that we may have won the contest of having the longest title on the session, and I'll read it out to you. So, towards automated and proactive anomaly detection in fiber access networks. So, just before we start and go into the details, a few words about the background. So, we all know that the internet services or broadband services are changing from just best effort internet to services that are critical for our daily life. And this puts increased requirements on the networks, for example, in terms of bandwidth, availability, and quality. On top of this, we also see a fierce competition among broadband service providers. So there's a price pressure not only on the network infrastructure, but also on operations. And we see this particularly in the Nordic region. So we want to address, in this research project, we want to address two of these aspects, so price and availability. So the target of what we're doing is to see if we can increase availability of the network and simplify operations. And our approach is to look at automation. We want to make use of the data that we can find from network elements. We need this data more or less real time, so we're looking at streaming telemetry. And our expectation is that this data varies in a complex way, so we need a tool not just having thresholds, but we need some tool to analyze the data and create dynamic thresholds, so machine learning. So what we want to accomplish then is to have a tool that enables detection of anomalies, and hopefully that we can do that before the services are affected, and then enable automated corrective actions. So of course this, as always, is this is easier said than done, and we need to combine expertise to address this challenge, and that's why we are so many here. So what we will talk about over the next 27 minutes is to put this research project into context. So Behnam Shariati from Fraunhofer will give you the context of the overall research program and also talk about an end-to-end network demonstrator that is currently being built. I will then focus on fiber access systems and talk about the field trial that we're conducting in Sweden, as well as about the packet processing pipeline that we're working with. And then Christian Burke, also from Waystream, will talk about the deployment that we're doing here, a customer deployment here in Germany, together with Infosim. And then finally, David Hook will talk about the toolbox that they're working with in this research program, looking at anomalies in various ways. And then we'll have the Q&A. Oh, just before we start, a few words about the organizations. I guess you are all familiar with Fraunhofer, but maybe you would like to say a few words.
Yeah, hello. So Fraunhofer is I think, the largest research organization, applied research in Europe, and we are Fraunhofer Heinrich Hertz Institute. So Fraunhofer Heinrich Hertz is actually a world leader in mobile and optical communication. We do have expertise in a wide range of activities, including data analytics. And concerning these particular presentations, we have several test beds that we are running them to do proof of concept demonstrations.
And Waystream, you probably may not have heard about us. We're a Swedish SME. We have been active in the fiber access area for some 20 plus years. We build fiber access switches and routers based on our own network operating system and hardware. And then,
yeah, maybe just very quickly on Infosim. We are based in Würzburg, north of Bavaria, and commercially we are selling a network management software, our own one called StableNet, and in the research projects we are looking into future approaches for extending network management towards AI, machine learning based approaches, various different other things, and happy to be in that consortium and to speak here. Thank you.
So Behnam.
Okay, thank you so much, Johan. Hello again, everyone. This is Behnam Shariati from Heinrich Hertz Institute. I'm going to give you a bit of context about the project. So Palantir, that was mentioned, is actually a subset of a very huge flagship project called AINet. AINet project is a Celtic Next program. 7 countries are involved in this research project. In total, 98 participants and a budget approaching 70 million euros. The project is running since 2020 and is going to end of next year with an effort of 500 person year. So that's a significant amount of activity taking place in this project. There are 3 main sub-projects: Antilas, which is led by Nokia; AINet Protect, which is led by Atran, previously known as ATFA Optical Networking; and Anyara is led by Ericsson. And today we are basically with the 4 of us here are with the AINet Protect, and I will give you a bit of more context about this one, which is basically focused on automated resilience and secure network for enterprise and society. AINet Protect is basically a project spanning 4 different countries: Germany, Netherlands, Sweden, and Finland. There are 39 partners with a budget around 27 million euros and 176 person year. So in this project, we are mainly focused on scalable network and node architecture. There's a significant focus on optical technology here, from the optical access network to optical transport, multi-layer technology like IP and optical. And there has been a lot of activity on making network telemetry at scale possible, and introducing intelligent controls, closed control loop to the network. And here we have leveraged AI and machine learning, and within that scope we also spent quite a lot of effort on security, for instance, quantum safe security networks. One of the big developments in the project is to bring all these technologies and solutions that have been developed with the partners into demonstrator and test beds. We will see a couple of small scale of them today, but a very large one is being built right now in front of our Heinrich Hertz Institute in Berlin, which I give you a bit of a context. And generally, Protect is really to develop a secure and autonomous enterprise network that delivers services to the end customer, provide monitoring to the operator that is monitoring them, and is safe and secure for the end user. AI Protect Consortium, as I said, there's 39 partners. You see the distribution of the partners here. There's a significant presence of Germany, then Sweden, Netherlands, and then Poland. Then you see that on the first, there are a couple of really big players, but there's a significant number of SMEs. That's also a very strong point of the project. There are plenty of SMEs into the project, including Waystream and InfoSim, and then there are large research organizations all involved here, including Fraunhofer Research Institute and several universities. That's going to basically end next year, and we are already in negotiation with funding agencies for a follow-up project at that scale to deliver the next technology for sovereign Europe. And then just a couple of remarks before I end. So the AINet Protect project has an overall architecture that approaches the basically the backbone network from the access to metro and core in an open and disaggregated fashion. So that's what, from our perspective, and also the operators that we are engaged with, they are driving to have a disaggregated ecosystem. They can bring a solution from different vendors. So that's what we're also promoting. But the key innovation is actually looking into the telemetry, streaming, monitoring, and with a key focus on privacy-preserving AI. So we have been developing also a data marketplace that offers data sovereignty and privacy for telemetry data usage. This architecture is going to be summarized with all the development into a final demonstration in Berlin. This is one of the examples of the test beds that we are running at Fraunhofer Research Institute. These are all based on commercial products and several prototypes that have been developed into the project. Basically, we have numerous optical access technology, including from Atron, from another technology from ATVA, point-to-point technology from Waystream, also a prototype of a terahertz link for extending access network based on technology developed in-house. We do have a couple of metro rings. This is optical transport. We do have a recent generation of optical transponders, including the ones supporting Z.Plus. And we are basically trying to run multiple of network slices end-to-end from access to the core, even connecting to the services that runs on the cloud or our high-performance computing cluster, and trying to basically run multiple of vertical services, medical vertical, industry 4.0 vertical, and then try to monitor the entire infrastructure such that it provides enough visibility and possibility to run algorithms that can detect anomalies and can address those issues. Then next, Johan will talk about a field trial that will be somehow represented in this later, and then the other colleagues will also talk about the next things. If you would like to also know more about this, or maybe you would like to test out the solution from yourself as a test environment, feel free to approach us and approach me, and we can discuss how that can be done. So I will hand it over back to Johan for the rest of the presentation.
Thank you. So zooming in on fiber access networks. What we would like to do in this research project is to have access to real-life data in order to be able to try out our tools. So we are running a field trial in the north of Sweden together with a company called Lunet. They could unfortunately not be here. So Lunet is a municipality operator located in Luleå, which is in the north of Sweden. You see it on the map there, just south of the Arctic Circle. They run an open access network connecting some 26,000 households. Their network, there are multiple, being an open access network, there are multiple service providers offering their services. They connect to their BNG, their service control point. Then there are several distribution nodes connecting to access switches that are connected in rings, and then to the end customer. So it's these access switches from which we collect data. So we collect streaming telemetry data on various kind of system parameters like temperature, power consumption, fan speeds, etc. We collect parameters on resource utilization like CPU and memory and buffer size utilization. There's data on interfaces like bitrate, packet rate, various kind of optical parameters, and also some parameters on service performance. And out of these 1,500 access switches that they have in the network. We are currently collecting data from a little bit more than 500 switches, corresponding to some 12,000 households. This data is pushed from the switches to a telemetry time series database, and we can select what kind of frequency that we want to push the data with, so down to 1 second. And now I think that the switches that we're currently collecting data from pushes data every 10 seconds, and this corresponds to 20 gigabytes of data per day. Then we use this data to look at pattern of particular parameters and predictability of the forecast that we do. So we have been looking at activity levels, defined as how many of the households that are active at a certain period of time. Look at traffic intensity, packet size distribution, etc. And this is the basis then for our anomaly detection. So the data that we collect, the streaming telemetry data, is then used as training data for our machine learning algorithms. We create forecasts and then add thresholds to these forecasts, and then we combine it with the streaming, with the real-life data to spot anomalies. This work is mainly being done by a couple of research partners. One of them is Savantic. It's a Swedish SME focused on machine learning and computer vision. And the other one is RISE, which is a Swedish research institute, a bit like the Fraunhofer Institute. To this data, we then add metadata from the network. It's information about network topology, about various aspects of the network elements, and also about customers. And altogether, this forms a health status about the network. So we have the health status. We can see when there are errors. We like to take fingerprints of a particular error situation, and this will then be the basis for possibly for automated corrective actions. Up until now, we have the machine learning that we've been doing so far has been kind of offline, so we use Python-based tools for doing machine learning. We are developing a tool, or kind of a real-time tool, based on open source platforms. So we use Telegraph basically to adapt the data that comes from the switches to Kafka. Then we use Kafka as a message bus, feeding both our time series databases as well as machine learning platforms where we use Vent2ML. And then this data, the telemetry data as well as the anomaly data, is fed into Apache superset where we plan to build interactive dashboards for network health monitoring. So using this tool, we plan to continue the data collection in the field trial, and once the error situation occurs, we can label this situation and use it for fingerprinting. On top of that, of course, we don't wish for error situations to happen in a live network. So in order to try out some specific error situations, we are planning to inject synthetic errors in the control way in the network, and then to analyze the anomalies that we can spot. And we're also planning to do performance testing of this pipeline and prepare this data. Now we're running this project up until mid next year, but we would like to make use of this vast amount of data that we collected over 3 years for future research projects. So that's also part of the work that we're doing. So then Christian is here to talk about what happens in real life.
Yeah, hi, I'm Christian from Wavestream. I want to tell you something about a short real-life story with our customer Zug. It's a little city network in Coburg. At the moment, they have about 800 access switches, and in a joint deployment with Wavestream and InfoSim, our 60 switches in use for over 1,000 households. Yeah, so it's a normal city network. So we go further. As I told before, Zug is a common customer of Wavestream and InfoSim. Through Zug, we thought about a small partnership, and they're using StableNet from InfoSim for the whole management. With this tool, they use the discovery jobs and automatic configurations. And then you see it on the picture, what you can build with these tools. Yeah. With StableNet, they could also push some customer ports in seconds. And for this, they have some templates. And so the workers don't need much knowledge for configuration stuff. Yeah. That saves much time and employees. And also, they will have a great view over the network with telemetry data. So now I'm handed over to David after my short presentation, and he will tell you something about telemetry.
Thank you. Yeah, so I'm happy to take the last part here of this presentation, showing a little bit more of the different challenges we're looking at from a research perspective as well in the project with regards to getting into the area of having a tool for that in the future and linking this to network management. So one of the challenges we are looking at is everything around telemetry. For us, it's not so much telemetry versus SNMP, but it's both going together with different scopes, with different approaches that both have their legitimation, I would say. Obviously, some of the promises we are expecting from telemetry, and everyone is expecting from telemetry, is to have much higher data rates in shorter time, better granularity for better analyses. In practice, we see a lot of challenges coming with that in terms of scalability, in terms of normalization of data. Unfortunately, it's not the case like we would have been expecting, that everything is standardized and everything looks the same and can be directly matched to each other. But anyway, those are the challenges, or some of the challenges we are looking at. So this is definitely one part. If anyone is interested in that, working on that as well, having first questions there, or first things you are looking at, that is definitely one of the things we are doing in the project, and we would be interested to exchange on that topic. On this slide here, we just have a few impressions how a proof of concept work. Some of the state is currently working. So for Waystream, we have this up and running. For other other specific technologies, other vendors, this is ongoing research to look at this and to look at interfaces. So you can see here just some of the views that probably most of you know from your network management systems, from your NOCs, like having data coming regularly in analyzer charts, like getting an understanding of the neighborhood on how all this topology is linked together, having just up-to-date performance data. And as I mentioned, it's really, it causes a lot of research questions to bring this all together with these new technologies coming up. And then on the machine learning side, getting back specifically to anomaly detection, something we are looking at there is not so much as a small medium enterprise. It's not so much about like reinventing the wheel and coming up with the next completely new anomaly detection framework that no one has had before, but it's more about putting together the different puzzle pieces, finding the right things, putting them into practical application, doing proof of concepts, how this can be worked with in the actual environment. Because what we have found out in many discussions with partners, with customers of ours that are closely following our research activities as well, we have found out that just not everyone has the time and the possibility to closely follow all the newest developments and machine learning themselves and get into all the different details, but they need approaches that they can be working with in addition to their daily job that they have to do. And with regard to that, we are actually working in two directions, which are somewhat highlighted here on that slide. On the right side, you rather see an approach with interactive notebooks. This is mainly Python we are working with because it's just one of the most powerful approaches where you have the most of the models ready available, where you don't completely put away the code, but you give people the chance to actually write their own code based on examples that are ready available. And this gives the possibility to do early prototyping and to early try out different things and apply apply actually the different machine learning frameworks that we have prepared and put together to the respective data of the network management system. And again, on the left side, you see a mock-up. Partly this is a running proof of concept, partly this is mock-up work, where we actually rather try to put away all this complexity of writing code themselves, of configuring all this themselves, and we rather try to somewhat pick the cherries out of all these different approaches that we are looking at and putting it into more simple menus that people can use it and handle it with getting and still get to valuable results. Here you see some of the work that is as well being done. This is a mock-up so far, so it's concepts put together based on what we have available in the Python notebooks. We have done a mock-up for a user interface. The idea here is that many people have approached us that they want to be able to have interactive possibilities to analyze the behavior of their network. So let's say you are historically looking at the last month and you see certain peaks in the network that somewhat don't seem to be normal. So there might have been some soccer game going on. There might have been some new update for Xbox that all the Xboxes of the world have been downloading in the same time. There might have been some known outages that you can find information about later on. And what we are looking at here is basically preparing a tool where people can combine the data coming from the network, from any network management system that's being collected, with some sort of an event store where they can actually, for instance, load in some, let's say, some iCalendars from all the Champions League games that are that you can find in the internet, or all other sorts of events that you want to load in, and then you can match the two, and this actually gives you a possibility to have a visual approach to filter on certain events to see whether they have an impact or not. And then in the next step, you can also use this if you have enough data, you have looked at the past, and these models have been created taking into account, for instance, Champions League games of Borussia or Bayern playing, then you can also use this for adequate forecasting. And yeah, there is one more slide here just showing this again in more the Python-like way. So there is also code available on this. We are constantly working on this. And it's yeah, just giving you an overview where the project's currently heading on our side, and looking always forward to having cooperation there. Handing back to Johan.
Okay. So now you know where we are, both in terms of the work that is being done at Fraunhofer, and you had this invitation from Benham to interact on their test beds. You've seen what we do at Waystream in the field trial, and what InfoSim is doing. So if you want to see how it goes going forward, the end-to-end field trial will be presented here in Berlin at the 6G conference in July next year. And if you want to interact with us, like in the introduction, we talked about tricky error situations. We are looking for things to try out in the testbed as well in the tool development. So if you have some proposals on things that you want us to look into, do feel free to contact us. David and I will be here throughout the day, also during the dinner, and I'm here until lunch tomorrow. But you can also reach us at these email addresses or through LinkedIn, for example. Finally, there's, like Benham mentioned, there are discussions now about the next research program. If you are interested in doing like Lunet and doing a field trial, do feel free to reach out to us as well, and then we can put you in contact with Lunet so you can hear about their experiences and what they have, well, how much work it has been for them during these last 3 years. So this basically concludes this part of the presentation, and then I guess it's time for the Q&A.
Thank you very much. So, do we have questions from the audience here or in Venulus? Please make yourself known. Nothing here. Do we have anything on the chat? Then maybe I have a question. So I personally have a data science background, and you talked a lot about telemetry collection and that you are interested in funky, interesting error scenarios from the audience. Could you give us an idea on which ones you already identified? So what were you actually able to see? I realize we're still in a proof of concept phase, but...
Yeah, so we've had a lot of discussions about this. Actually, we have a little bit of different views on how to do this in the project. So we have the operator LUNET, and they would like to have the tools to start from that aspect. So use the tool, see if we can find anomalies or outliers in the data, and then check if something happened in the network. And then there's the other perspective of starting with the error situation and see if we can find anomalies in the data. So this is what we have been debating a bit. There are some things that since this is an open access network, one thing that we have discussed is what if we lose one of these service providers? Can we spot this before everybody starts calling and the service desk gets downloaded? So that's something we discussed. Yeah, we also talked about these things like denial of service attacks and if we can spot those things. But what we would really like to find out, because one of the targets was to simplify operations. So if there's something where by finding a complex error situation where we can avoid truck rolls, for example, that would be really a neat result.
Thank you. And now in this community, they know everything about how things can go wrong, so please go ahead and approach our speakers.
So if you think of something that you would like us to try out that doesn't ruin the LUNET network, then please feel free to reach out.
You know how to break things, people, come on. Okay, so I don't see anything, so thank you very much.
Thank you.